Hi everyone, welcome to another episode of Lakeflow Declarative Pipelines. This episode is going to be an introduction to streaming tables, where we will learn purpose and use cases for streaming tables. So here is a more detailed agenda. We will start by examining syntax and the key attributes for streaming tables. And then we'll move on to demo section, where I'll explain the project folder walkthrough. So we will be using this project throughout this course. Next, we're going to generate a sample data that we are going to use in our ingestion pipelines. We'll create first simple streaming table using basic configurations and inspect the result of pipeline execution. So we will examine streaming tables in Declarative Pipeline Editor as well as Unity Catalog. Next, we're gonna explore extra streaming table properties. There are quite few attributes that you can use to configure streaming tables, so we will explore some of the most common and important attributes. As a next exercise, I'll demonstrate incremental nature of streaming tables. Finally, we'll wrap up with exploring temporary streaming tables that do not create objects in Unity Catalog. Let's get started. So in overview episode, I mentioned that there are two primary data objects that you can create within Lakeflow pipelines. So that's streaming tables and the materialized views. So what makes streaming tables outstanding? So why should you create streaming tables as opposed to materialized views? I would highlight two key benefits. First of all, streaming tables are always incremental. So because they are based on Spark structured streaming, they inherited incremental nature of Spark structure streaming, which means that you don't need to do much to build incremental pipelines. Another big benefit of streaming tables is its low latency. If you run pipelines with streaming tables continuously, you can get near real-time pipelines, which are critical when you need to build low latency pipelines. So streaming tables cannot ingest from all data sources that are available to Databricks, but there are few data sources that you can ingest from. So these are raw files that are located in your storage. For example, you can ingest from the files inside your Unity Catalog volumes. Then you can ingest from Unity Catalog managed or external tables. You can also ingest streaming tables from other streaming tables. And finally, you can ingest from streaming services like Event Hub or Kafka. Now, where you can write within your declarative pipelines from streaming tables. So you can push the data from streaming tables to Unity Catalog tables, whether it's managed or external. You can also write into other streaming tables as well as streaming services like Event Hubs and Kafka. So in terms of limitations of streaming tables, there are only some limited number of sources and destinations from which you can read or to which you can write from streaming tables. So examples, you cannot create a streaming table pipeline from databases, for example, Microsoft SQL or Oracle. Likewise, you cannot write to these tables using streaming technologies. Another limitation is related to transformations. Some transformations that you can apply within streaming tables are supported but require special care. For example, in some cases, you have to apply watermarks. On the other hand, some transformations are not supported at all. So examples could be pivoting or distinct transformations that needs to have entire dataset context. If I oversimplify, the best use case for streaming transformations are lightweight, simple transformations. Now let's talk about usage syntax for streaming tables. So in order to use streaming tables, you have to, first of all, import related pipelines libraries from PySpark, like I have here. And then you have to use these pipelines as a decorator and use table method here and provide some attributes. Finally, you have to provide Python function that will include your transformations. The Python function should return a data frame, and this data frame can use some of the streaming methods like read stream. So for those folks who are familiar with Spark structure streaming, will recognize this command. So this is one of the key read APIs for streaming data frames. So you can use read stream to read from Delta Lake table and other streaming tables using this syntax, or you can use it to load from some data sources like storage, Event Hub, or Kafka. So this is important because if your function definition does not use streaming APIs, then your resulting data object will be materialized view rather than streaming tables. So in other words, definition of your function determines what kind of object you will get in your declarative pipeline. Now let's talk about table attributes. So these attributes are all optional. You may or may not include them, but it's best practice to include these attributes. So let's start with the name attribute. Name attribute defines the name of the object that will be created in your Unity catalog and pipeline. So if you don't provide name attribute, declarative pipeline will use your function name to create table object in Unity catalog. A comment is another optional attribute which allows you to provide some free text attributes. So for example, you can specify purpose of this table or medallion zone associated with this table. Path is another optional attribute. So by default, if you don't specify path, your streaming tables will be created as managed tables. But if your location of the table is important for you and you want to specify path, then you can do this. You can also use partition columns attribute, so that could be useful for performance optimization purposes. Next, schema attributes allows you to define schema, but it's also optional because if you skip this, schema will be inherited from your transformations. Finally, the private attribute decides if you want to create a permanent object versus temporary object that will live only during execution of your pipeline. So if you set it to true, then streaming tables will not be created as a permanent object in your Unity catalog. Default value for this attribute is false. This concludes today's discussion. To recap, we have learned key benefits of streaming tables as well as its limitations, main use cases, sources, and the targets that streaming tables can be ingested from. Thanks for watching, and I'll see you in next episode.